Geometry, Unit 4, Section 3, Triangle Congruence. For Section 1 and Section 2 are what we refer to as drawing conclusions based on some given information. If you're told this is an angle bisector, what does it mean? Well, it means the angle is cut in half, you get two congruent angles, things like that. Well, what this was all really leading up to was triangle congruences. I want to be able to prove that two triangles are congruent from some given information. Now, if two triangles are congruent, such as these two triangles that we see here, get my pen up, we would say that triangle ABC is congruent to triangle. Well, I gotta make sure I got to correspond my order here. So angle A has one arc that corresponds to D. That has one arc. Angle B, double arc, corresponds to E. And angle C, triple arc, corresponds to F. So triangle ABC is congruent to triangle DEF. And what that means is all corresponding sides, well, let me say this actually. I'm going to change that. All three pairs of corresponding sides, so that would be AB is congruent to ED, and BC is congruent to FE, and AC is congruent to FD. So all three corresponding sides and all three corresponding angles are congruent. And so that means that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F, and so on. So everything that corresponds is congruent, which means the triangles themselves are congruent. So if I want to prove these triangles are congruent from some given information, you could prove that it has three pairs of corresponding angles congruent and three pairs of corresponding sides congruent, but that's actually overkill. There are ways to prove triangles are congruent without getting all three angle pairs and all three side pairs. In fact, there's several ways to do it with just three congruencies, with two sides and an angle, like two pairs of sides and one pair of angles, or two pairs of angles and one pair of sides, or just with the sides, no angles. So there's different ways to prove triangles are congruent. In the end, what we're saying is that all corresponding sides are congruent and all corresponding angles are congruent. The triangles themselves are congruent, but we don't need to prove every angle pair is congruent, and we don't need to prove every side pair is congruent to obtain that. We can just get a certain set of three. So there's different ways that we could do this, and that's kind of what the rest of this chapter is on, is how are the different ways to do that and how to set up a real triangle proof to go along. Now, what this next thing here is, this is basically your cheat sheet. This is all the stuff that came out when we were drawing conclusions. These are all the things that'll go in the reason columns. We're going to do statement and reason proofs. And anytime we make a statement, we're going to say one of these things. Midpoint splits a segment into two congruent segments. Vertical angles are congruent. A line bisector cuts a segment into two congruent segments. An angle bisector cuts an angle into two congruent angles. Perpendicular lines form right angles. All right angles are congruent. These two go together. Two angles that form a linear pair are supplementary. Supplements of congruent angles are congruent. These two go together. Angles opposite congruent sides of a triangle are congruent. That's from your isosceles. Whenever we're given an isosceles triangle, that comes up. Alternate interior angles of parallel lines are congruent. Corresponding angles of parallel lines are congruent. Sometimes we do addition. Sometimes we do subtraction. Sometimes we have the reflexive property. This isn't everything, but this is a lot. So if you're ever wondering how do I say that thing about angle bisectors, well, use this as kind of a cheat sheet to help you in the beginning. Eventually, it should become kind of second nature. So what we're talking about today is side angle side triangle congruence. And what we're saying here is that if I have two triangles and some given information, and through that given information, I could show that the two triangles have two pairs of corresponding sides congruent and one pair of corresponding angles congruent, and the angles actually between the two sides, that's enough to say the triangles themselves are congruent, even though there's six congruency pairs between two triangles. They're the three angle pairs and the three side pairs. But I only need really three pairs. And from that, we could say, well, because of this, that means the rest of the pairs have to be congruent also. But why does this work? Well, what I'm showing here aren't triangles, but I'm going to draw triangles. I'm going to say that this line segment here is the same length as this line segment, and this line segment's the same as this line segment, and this angle marked is the same as that angle mark. And what I'm going to attempt to show you here is that no matter how I draw this line, there's really only one way to do this, by connecting these two lines. There's no other way for me to make a triangle out of this except that. And the same thing here. And these two triangles are indeed congruent. If you take your ruler and measure, this third side is going to be the same length. This this angle over here is going to be the same as this angle over here if you use your protractor. And this angle over here is going to be the same as this angle over here. So I don't need to prove all 6 pairs of congruencies are there. I can just prove a side, an angle, and a side of one triangle is congruent to the side, an angle, and another side of the other triangle, what we call it side, angle, side. Then that's enough to prove the triangles as a whole are congruent. Let me show you an example. So this is what your standard proof questions look like. You have some given information, a picture, and what I want to prove. So first, you always want to start with what you want to prove. I want to prove that triangle ABC is congruent to triangle DBC. Now, with rigid motions, it's very easy. Just reflect over BC and be done with it. But as far as a statement reason proof goes, it's a little bit more. So make a statement reason table. Statement and reason. And so set that up. I don't want to use red lines. Let me go back to a black line. So set up a statement reason table, and we're going to try to prove these two triangles are congruent, and we should end up with a side angle side relationship to do so. So once you get more used to this, in the beginning, sometimes we just kind of read the givens, what do they mean, read the given, what does it mean, and see what kind of falls out. But it's good to kind of make a plan, maybe kind of look at this stuff and think about it before you put it down here, because you don't want to have to erase or cross things out. So always keep in mind you're looking for 3 congruency pairs. If I get 3 congruency pairs, that often means I have enough to prove the triangles are congruent. And in this case, we're looking for a side angle side out of the 3, and I'll explain what that means. But then in the next couple of lessons, you're going to see side, 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 angle, hypotenuse leg, and a whole bunch of different ones. But B is the midpoint of AD. So B is the midpoint of AD. What does that mean when you're given a midpoint? Well, if you don't remember, take a look at your cheat sheet. The top one up here. A midpoint splits a segment into 2 congruent segments. So if B is the midpoint of AD, that means that AB is congruent to BD. Okay, I'm going to put that down, but let me kind of plan out this whole thing first. So that's one congruency pair right there. You got this side of this triangle is congruent to this side of the other triangle. That's one congruency pair. Then you have AD is perpendicular to BC. AD is perpendicular to BC. So where these lines meet, perpendicular lines form right angles. Perpendicular lines form right angles. And all right angles are congruent. So that means that this angle, which I'll call angle 1, and this angle, angle 2, must be congruent because they're both right angles, and all right angles are congruent. And do I have to call it angle 1? No, I could call it angle ABC. I can't call it angle B because there's multiple angles at vertex B. So I like to number them. It's a little bit easier. And then that's our second pair right there. So I have a side congruency pair between the two. I have an angle congruency pair between the two, but I need a third. And what you'll notice is that BC is a common side to both triangles. That's what we call our reflexive property. So that's going to be our third one right there. And when I look at this, I see a side, an angle, and a side. And that's congruent to the side, an angle, and the side of the other triangle. So that is enough. Do I know that this is congruent to this from the given information? No. But I do know that if I have side, angle, side, like we do in this case, then that means the triangles themselves are congruent, and then all the other corresponding stuff is congruent also. So let me put this down here. B is the midpoint of AD. And this was given information, that's why I'm allowed to say it. Anything up here, you put given in the reason column. All right. And then what we got from that was that AB is congruent to BD. And our reason, again, if you don't remember how to word it, use this as a cheat sheet. A midpoint splits a segment into two congruent segments. All right, so right there, got that. Next up, and this is really how I like to do proofs. I write a single given down, and then what congruency do I get from it? Next given, what congruency do I get from it? Some teachers will say, put all the givens down as once and then do that. That's just not the way I prefer to do it, but some people do, and that's okay if you do. But the next given, which I treat separately, AD is perpendicular to BC, is given information. And separate that. And then when it comes to perpendicular, we have two steps we have to do. We have to say that angle 1 and angle 2 are right angles because perpendicular lines form right angles. And then we have to say, then we could say they're congruent. So when it's perpendicular, you can't jump right to that angle is congruent to that angle. You have to first say they're right angles, and that's why they are congruent, because all right angles are congruent. Sorry, this video is a little long, the first one. First one of the chapter is usually a little long. Done in a second, though. So the last thing, so what I like, it's also helpful to kind of on the side put that we have a side congruence here. We have an angle congruence here. And our third side congruence came from BC is congruent to BC. And that seems obvious that something is congruent to itself, and that's true, but we still want to put it down as a reflexive property. So you put that down. Anytime they share something, we call it reflexive because BC is a side to both triangles. And that also is a side congruency right there. And so now that I have a side, an angle, and a side congruency, and it's got to be in that order too. Notice that the angle is between the two sides. Like it couldn't be this angle in these two sides. That wouldn't flow. Like side, angle, side means when I go around the triangle, it's a side congruence, then an angle congruence, then a side congruence. And so now that I have that information, that is enough information to say triangle ABC is congruent to triangle DBC. And our reason is side, angle, side is congruent to side, angle, side. And so that's really what we're trying to do here. And we're going to practice these proofs tomorrow, that they're going to come out to be side, angle, side proofs. And then in the next couple of days, we'll see about angle, side, angle, and side, 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 and angle, angle, side, and different ways to do that. I'll try to make the videos a little shorter. This one's a little long because it has a lot of intro stuff to it. But this is really an important topic, and how you say things is key. Definitely use this cheat sheet, especially in the beginning. All right, see ya.